Hey, what's up, AP Calculus students? Today we're covering 4.4 Part 2. So we're just going to do some word problems and a little bit more work with the tougher type of derivatives that we have to do using our logs, natural logs, and exponential stuff. So the first thing it's asking us to do, and this is kind of weird, but I want to throw it out there to you because it's good to break down problems, especially ones that are more difficult to figure out. There's a lot of things going on here. So it says a line with slope m passes through the origin and is tangent to y equals ln x. What is the value of m? All right, so let's kind of think this through a little bit. So we have this graph, right? And it says that it's tangent to y equals ln x. So ln x looks like this. It's an exponential function, so a logarithmic function. So it looks kind of like this in general. So what they're saying is that we have this line, right? It passes through the origin and is tangent to the line at some point. It's kind of like that. Keep in mind it's not the most accurate, but that's the idea. So at some point here, this line is tangent to the line ln x. So it's asking us, what is the value of m? So one of the keys here is we're talking about slope. So when we're talking about slope, we want to figure out, okay, so when is the slope of ln x going to be tangent, right? So we're trying to find the tangent slope. So let's go ahead and do that. Ln x. Well, we know we have to do the derivative with respect to x of that. So that's going to be 1 over x. All right, so we have some point here at A. We're going to call it point A, where the slope is going to be tangent to the line. So what we're going to do is say, well, our original function is this. So we know that ln of A is going to be equal to, wait, let me think this through. I just had it in my brain and it kind of slipped me. Oh, so at A, then our ln A is where we're at. So this is going to be our x and y. Yeah, okay. So let's do that again. So we're looking at some point A, and the value at that point would be ln A, right? So that's going to be the given for our line. So what we know that is ln divided by A is going to be equal to the slope at that point, which is 1 over A. And we're taking it from there, and we're just saying that the A is the specific x value for that situation. All right, so what we're going to do here is we're going to go ahead and solve, right? So let me explain that a little bit better. So this point here is at A ln A. The slope at that point, right, because we're trying to find the slope, is going to be, well, the difference between the change in y, right, would be ln A over the change in x would be A, right? So we said that that's going to be the slope of this line, but we also know that by doing the derivative, it'd be the same thing as 1 over A. Now let's go ahead and solve this for A. So notice that we have A's in the denominator, so if we multiply by A in both sides, those all cancel out. So we have ln A equals 1. Now remember that we have the rule from pre-calculus and Algebra 2 that if we do e to the ln, that they cancel out. So A is going to be e to the 1 or just e. All right, so the value of m has got to be equal to e to satisfy this situation where we're going to have this tangent line to y equals ln x that passes through 0. Okay, so I just wanted to throw it out there just to make you see how we might set something up and how what they're giving us can help us to find what it's asking us, even though it's kind of tricky, but it's good practice. Okay, so this one is a straight derivative, and we're going to do a couple derivative stuffs just to make sure you understand how to do them. So notice that this one goes along with the one that says that the derivative with respect to x of log base a of a to the u is going to be the same thing as 1 over u ln a. And then if we have the chain, right, so you could say du dx. Okay, so we're going to do 1 over, we have sine x is our u, right, this is our u, and then ln of a, and then we're going to do the chain. So we have the chain of sine x is cosine x. Oh, sorry, we did this wrong. All right, so this is true. So our u is actually this whole thing here. So this is, the form is wrong. I wrote it wrong. Log base a of u. Sorry for the mix-up. All right, so yeah, so our u would be a to the sine x. So when we do this, then we have 1 over u is a to the sine x ln a. And then we have to chain it, right? So our chain, the derivative of a to the sine x would be a to the u is going to give us, let's just make sure I have it correct here, is going to be a to the sine x ln a. But then we have one more chain, right? Because we have this inside function now, so then we have cosine x. There we go. All right, so what we have, let's write this all together so it's easier to see. Right, so the top and bottom are exactly the same. So we can cancel out, this whole thing is just going to be cosine x. Right, so this is actually a 3 chain. So we had the first chain here where our u was a to the sine x, right? And then once we got to the second part of that, we derived a to the sine x, but then we had this second inside, so that would be the second chain in our derivative. And then luckily we were able to cancel a bunch of stuff out and came out pretty nicely as just cosine x. Okay, on to the next one. So this one, we're looking at x to the x. So for this one, we're gonna use some of our algebraic properties. So because we have the x in the exponent as well as its base, we can't just go ahead and straight do one of our rules, right? Because it's not gonna be a chain rule because we have an x and then an x again. It's not going to be a product rule because they're not multiplying. Definitely not a quotient rule, right? So there's no rule that governs this thing right here, but we can use some algebra. So let's go ahead and do that first. So remember from Algebra 2 that if we want to get to our exponent in our, well, if we want to get to our variable in the exponent, what we did was we took the ln, or just log, but more commonly we use ln of both sides. So we have ln y equals ln x to the x. Now remember, once we do our log or natural log of our function, we're allowed to drop our exponent down in front. So we have x times ln x. Now this makes it a lot easier for us at this point to do the derivative. So let's do the derivative here. So the derivative of ln y is 1 over y. But we remember that we need to do dy dx here, right? Because we're deriving with something, we're deriving a variable other than what we're deriving with respect to, which is x. Okay, the second part of this, now this is going to be a product rule, right? Because now we have x times ln x. This is not going to be too bad. So our u is going to be x. Our du is going to be 1. Our v is going to be ln x, and our dv is going to be 1 over x. So let's put this all together. U dv plus v du ln x times 1. Alright, we're getting there. Let's simplify the left side. So x times 1 is x, divided by x is 1. So that's, the first part is 1 plus ln x. Now we want to solve for dy dx. So let's multiply by y here to get rid of that. So dy dx is going to be y parentheses 1 plus ln x. Now if you wanted to, you could go ahead and distribute it out. Y plus y ln x. But either way should be good. Either way looks just as simple as the other way. Oh, sorry. Forgot to plug in here. We know what y is equal to. Y is equal to x to the x. So let's go ahead and substitute for this y. Let's write that one here. So in place of this y, we're going to say that y is the same thing as x to the x, and then 1 plus ln x. So we have it all in terms of x. That comes out nicely. Okay, so the last one, I think this is very appropriate and relevant to our time now. This could be the spread of flu, it could be the spread of COVID, it could be the spread of any disease. So let's see how we can use calculus to figure out different information from our model. So our model says that for the spread of flu, P of t is equal to 100 over 1 plus e to the 3 minus t. Okay, so it says find the initial amount. Well, this is just an algebra 1 problem, right? Because initial amount just means, all right, if P is 0, then what is our number of people? So we're going to plug in our 0, we're going to do 100, and I'm writing out how I'm going to put it in my calculator. So parentheses, right, because this implies parentheses from our fraction bar. We have 1 plus e to the 3 minus t, close parentheses. So this parentheses, that parentheses, this parentheses, and that parentheses all match up. So we're going to go ahead and put it into our calculator just as we wrote it out. Maybe I should come and show you what it looks like over here. Alright, so let's do 100 plus e to the 3 minus t. Oops. So we're going to do 100 divided by 1 minus, okay, so you have this button here, e to the x. You could also just put in an e. There's an e somewhere here, and do the caret. Oh, the e's here, and then do the caret. But it's just a lot easier if we just do e to the x. right? And then we're going to do, what was it? 3 minus t. 3 minus, we don't have a t, so we're going to put an x in there. And then make sure you close the biggest parentheses. Okay, so we can hit enter. And then, wait, I think I put in something wrong. That's weird. It shouldn't be that big. Oh, hello. X should be 0. 100 divided by 1 minus e to the, let's see if it'll do it without parentheses here. E to the 3. Oops. Delete. What's going on here? There we go. E to the 3. Ah, it's a plus. Keep screwing it up. Clear it out. 100 divided by 1 plus e to the 3. Alright. Finally. Okay, so we'll round that up to the nearest person. So that would be 5. I'm not sure what I did to my pen. Okay, here. So this is going to be 5 people. Okay, number 2. How fast is it spreading after 3 days? So remember, this is how many people total. So if we want to find out how fast, then we're talking about the rate of change, which means the derivative. So for this one, because it's talking about a rate of change at 3 days, we need to go ahead and do our derivative. So let's rewrite this. Let's put that denominator as a -1 exponent so that we can power rule that. And then we have an inside chain. So let's go ahead and do the derivative of this with respect to t. Alright, so the 100's not going to be affected. This though, we're going to drop down the 1, so we're going to have -100. 1 plus e to the 3 minus t. And then we're going to subtract 1 from our exponent. Right, then we're going to chain rule this. We have this whole inside to deal with. So the 1 derives out, which is nice. E to the any power is going to derive to be itself. But then now we have this chain to deal with. So 3 times negative t, well, the 3 minus t, the 3 is going to derive out, and then the negative t derives to -1. Okay, so we got all our chains here. Our -100 times our -1 is +100 again. And then we have e to the 3 minus t here, still in the numerator. There's no negative exponents on it. And then we're going to divide it by, right, because we're going to reciprocate, 1 plus e to the 3 minus t squared. Okay, so if we do that and we punch that into our calculator, go ahead and do that. (100) e to the 3 minus, it's saying after 3 days, right? So our time is 3. So we're going to do, and then we did 3 minus 3, which is 0, right? E to the 0 over 1 plus, oh, this is going to be e to the 0 again. So e to the 0 squared plus 1 squared, whoops, squared, what we end up with is 25. Okay. So the rate is 25 people. This would be people per day. And then the last thing it's asking us is when is the maximum rate of spread? So what we can do here is we could graph P of t, right? And we would try to find when the slope is the highest. But the more elegant way, because we can do the derivative and because we already did the derivative and we know what it is, it's going to be 100 e to the 3 minus t, 100 e to the 3 minus t over 1 plus e3 minus t, 1 plus e3 minus t squared. Right, we can graph this and just find when it's equal to 0. So this is the derivative. And we're trying to find when that's equal to 0 because remember we said that for our derivatives, when we want to find our maximums, our minimums, we just set our derivative equal to 0 and then go ahead and look at where that's on our graph. So let's go ahead and do that. Let me type it out first, just so we avoid that same mess that we did or that I did last time. 100 e to the 3 minus t divided by 1 plus e to the 3 minus t squared. Okay, let's switch back to my camera. So there it is. We're going to hit graph. We're going to watch it graph. Oh, so we can't see our maximum here, but what we can do is we can zoom out. And just so we make sure we zoom out from an okay place, I'm going to put it someplace that looks like where we might be looking at. So we're going to hit enter. Okay. So now what we can do here is we can find out when our slope is equal to 0. When is our derivative equal to 0? Sorry, it's cutting out. Focus here. Wait, did I do something weird? Alright, well, let's just trace this and see that this point up here is about 3. Alright, it's between 2 and 3. So we're going to just say that, I'm not going to do anything fancy here. We could find the maximum, but we're going to just estimate here. And we're going to say the maximum rate of spread is at 3 days. Okay, I apologize for the hiccups here. Sorry, I brain farted a few times, but you should get the idea. Good job today. If you have any questions or need any help on this stuff, then we can work through them together. All right, good job.